Hi, let's look at this differentiation question where we are given that y is equals to 3 sine 3x plus cos 3x, and we are asked to prove that the second derivative of the expression is equals to minus 9y. Alright, so let's go ahead and look at this. So first we have y equals to 3 sine 3x plus cos 3x. Alright, so we need to remember that if I differentiate sine ax, I'll get cosine ax, and the a comes in front. Alright, and similarly if I differentiate cosine ax, I'll get negative a sine ax. Alright, so with that understanding, we can move on to the next step here where I differentiate. Okay, so when I differentiate this, I'll get 3. So this 3 comes in front, and differentiate sign will get cosine 3x plus, okay, so differentiate cosine will be minus sign, so minus the 3 comes in front, 3 sine 3x. Okay, so let me solve this first. So I'll get 3 times 3, which will be 9 cosine 3x minus 3 sine 3x. Alright, now let's do the second derivative. So second derivative, the d2y dx2, which will be differentiating the first derivative, and what I will get is 9, and the 3 comes in front, so cosine, differentiate cosine is minus sign, so it's minus. Okay, so maybe let me rewrite this here. So differentiate cosine is minus sign, so minus 3 sine 3x minus 3, and differentiate sign is cosine, so it will be 3 cosine 3x. Okay, so let me solve this. So this I'll get minus 27 sine 3x minus 9 cos 3x. Okay, now if I were to factorize out the minus 9, okay, so over here I can see that there is some similarity between this expression and this expression over here. Okay, and the main thing is the coefficient of both the terms is different. Okay, but we can see that a common factor of minus 9 can actually be factorized out. So if I factorize out minus 9, I'll get 3 sine 3x plus cosine 3x. Okay, minus 9 times 3 will be minus 27, and minus 9 times plus 1 will be minus 9. Alright, and from this you can see that this whole term here is actually this term here, 3 sine 3x plus cos 3x. So which means that this is now equals to minus 9y. Alright, so we have proven this expression here. Alright, thank you for watching. I'll see you in my next video. Bye.